Okay, so in the previous tutorial we have seen how we can add this top state name transition, and now let's see how we can add a pivotal name transition, which means like for example, now if the character is going to a forward direction and if he suddenly changes its movement to the backward, you can see there is a instantaneous transition to backward cardinal direction cycle animation, right? So this is fine, but in order to add much more realism, what we can do is when the character is making a sudden transition for the opposite direction, we can play a pivotal animation, which means like he is trying to get some change to that specific direction, and then we can play the cycle animation accordingly, right? So it won't be a direct transition like this, right? You can see now if the character is quickly changing the direction for a opposite direction, the animation transition is instantaneous, right? But if we add the pivotal animation, this would be much more smooth, right? Okay, so let's see how we can do that. So I believe we have to add another state called pivot, right? And maybe I will move this chunk of states to here, right? And pivotal state to here. Right. So this is the state, pivot state. So from pivot, we can jump to cycle. Also from pivot, we can jump to stop state as well, right? And then we can go to the idle state as well, but I think if we add it like this, it will be bit more unclean to manage. Therefore, let's add another state alias. So I'll add state alias, call this as idle alias, right? And it will be pointing to the idle state, right? Basically, like it's a shortened form of this transition, like this is exactly same as pointing to this specific state, but instead of attaching it to here, now we can attach this to here, right? So the diagram would be much more clean, right? And then there are multiple different ways where we can jump to pivot state as well. So let's add another idle source called pivot sources. Pivot sources, yeah. And there can be multiple different pivot source. So obviously start to pivot is possible and cycle to pivot is possible and stop to pivot is also possible. So those are the possible transitions, idle source, pivot sources, and from those sources we can jump to pivot state, which is here, right? And then from these pivot sources fail somehow, if this transition is fails, there should be a countermeasure as well, like we did in these idle sources, joke sources, things like that. I think maybe we can rename this as stop sources, right? It will be much more meaningful, right? No, maybe let's keep it as job sources for now. Later on, let's make those changes if required. Yeah, so the point is, as a countermeasure, we have to add another transition from pivot sources to stop state as well. In case this transition fails, then we can jump to this state. Right. Okay, I'll clean it a little bit. Yeah. Now we have all the possible transitions and state. So now let's go and implement this specific state. So let's go to the pivot, and like we did before, maybe we can add a sequence evaluator here, but I think for the pivotal animations maybe we need a much more sophisticated state machine here, because it may involve multiple different state transitions within that pivotal state. So therefore I'll add another state machine, and I'll rename this as pivot SM, right? And then inside this pivot SM, let's add a new state called pivot. Right? And inside this state, now let's add a sequence evaluator, and as usual, let's make it as dynamic and explicit time as dynamic, and you don't need to expose it as a P. Plus it shouldn't loop, and it shouldn't teleport to specific explicit time, right? Okay, then then maybe we can start implementing setup pivot anim layer inside this on become relevant, right? So on become relevant function, I'll name this as setup pivot anim layer, and move it to anim node functions category, right? And like we did earlier, let's get the node and convert to sequence evaluator, and we can set the sequence based on the cardinal direction for a specific sequence. Plus let's set the explicit time as 0, right? But I think instead of using what we did at these sort of levels, we use the local velocity direction, right? But I think instead of using this velocity direction, now we have to consider somewhat different approach, which means we have to determine what is our direction based on the velocity is changed, right? Based on the acceleration is changed, right? Not the velocity, because the pivotal is triggered, or pivotal animation plane decision should be taken based on the acceleration, not the velocity. So I think, do we have a function called update acceleration data? No, right? Yeah, so maybe we need to define a new function like this inside our blueprint. Let's say update animation to get those acceleration related data, right? And based on those acceleration related data, we can do that pivotal change, right? So let's create a new function called update acceleration data, and make sure to mark it as thread safe, and I'll move it to the blueprint thread safe functions category. Right now, similarly, we can call this function soon after this update velocity data function has been called. I'll plug it to here and go inside to that function, and let's start implementing it. Right. So first, let's capture the world acceleration. So I can get the property access node and get movement component. Do we have a function to get movement component? Let me see. Get no, right? Yeah, so let's create a new function called get movement component, right? And these are actually blueprint thread safe function as well. So I'll move it to here, and no, maybe this is not a thread safe function. Instead, maybe we can mark it as a helper function. So I'll mark it as pure because we are only getting it. So let's get the property access node here, and let's get the try get pawn owner, and there we have get movement component, right? So this is a generic movement component, but we need this character movement component. So let's cast to it, and let's return the value, and I'll rename this as return value. So if this is casting is valid, we can return a possible reference for that specific character movement component. If the casting is failed, then we are simply returning a null reference. Okay, now inside this update acceleration data, within this property access pin, we can call that get movement component function, and it should have something called get current acceleration. Yeah, this function. And we need to be only aware of x and y related accelerations. So therefore we can cut down the z-axis by multiplying it by 0 and multiplying x and y with unit vectors, right? Which means 1 and 1. I'll promote this to a variable called world acceleration 2D, and maybe assign it to a category as well. We have world velocity data. Likewise, maybe we can assign this to what? Yeah, maybe we can make this as a local variable, I suppose. So I'll make it as a local variable, world acceleration 2D, because we have to be really careful with these local and global variable convention when it comes to the animation blueprints, because sometimes it may involve some random issues if we have a global variable, because we are following that thread safe fashion, right? So sometimes thread should manage their own resources instead of waiting for the global resources. That's why actually we have to be really careful when you're determining these sort of variables, right? So I think it is safe to define world acceleration 2D as local variable, but in case if it has some issues, maybe later on, if required, we can make it as a global variable, right? But for now, I think it's safe to keep it as local variable. And then based on that world acceleration 2D and based on the world rotation variable, let's unrotate this vector, and it gives a local acceleration 2D, and we can promote it as a global variable. So it should be local acceleration 2D, and I'll assign it to a category called acceleration data. Right. And since this function is responsible for handling acceleration, we have, I think we already have a variable called as acceleration inside the character state data. So we can manipulate this variable as well inside this function. So let's say if our local acceleration 2D is, we can get the vector length xy squared, right? So xy squared gives the c velocity vector length, c acceleration vector length, and let's say if this is nearly equal to this error tolerance value, we can determine whether we have acceleration or not. So this is just a quick check of accelerations inside within this function. Now I think we had somewhat similar calculation at here as well, but this one is actually provided by the component level itself, right? To the component level itself, we do a calculation and pass it to the animation blueprint level. But similarly, we can do a calculation inside this animation blueprint instance as well, since because of we have this variable, right? Right. We can do a recalculation for the acceleration, and now we can make a calculation to determine the pivot direction as well. So we can do that. Yeah, so let's first create a variable called pivot direction 2D. I'll make it as a vector and push it to the acceleration data, and I'm going to set this variable now based on certain calculations. So first let's get the world acceleration 2D and normalize it, and then we have to lerp this world acceleration with this pivot direction 2D. So let's get the get instance of this pivot direction 2D and lerp the vector. For the alpha, I'll make it as 0.5 and normalize it as well. Right, and then plug it to the pivot direction 2D. So basically what we have been done was we have been normalized the world direction, and based on that world direction normalized variable and the pivot direction 2D, we lerp it and normalize the final output and pass it to the pivot direction 2D. Right? And then by using this pivot direction, the normalized value, and the world rotation, we can calculate the direction. this one, I think first one. So we can calculate the direction, and we can select cardinal direction from angle by using this specific angle. And for the dead zone, I think we have the cardinal direction dead zone to be plugged, right? So we can pass the current direction as forward for now, and since this is a pivotal change, we have to get the opposite direction pointed by this specific direction, right? So do we have a function called get opposite direction? No. So let's create another helper function called get opposite cardinal direction, right? And then I can pass it to the helper functions, and I'll make it as pure, also constant, also thread safe. Okay, and then it simply pass the current direction as the cardinal direction, and its return value also should be a cardinal direction type, right? So let's use switch on cardinal direction, and if it is forward, the return value should be backward. If it is backward, return value should be forward. If it is left, return value should be right. And finally, if it is right, the return value should be left. Right? So this function will return the opposite of this pointed cardinal direction. Now we can use that helper function inside here to get the opposite of the cardinal direction, and I'll promote it to a global variable called cardinal direction from acceleration, right? Okay. For the category, I will assign it to locomotion state machine data, right? Okay, so that is how we can calculate the cardinal direction from acceleration. But shall we try to debug it to check whether it's working properly or not? So if I play it now, let's play it on the editor mode, and the output log is enabled now, right? Yeah, see that pivotal change related cardinal direction is now properly printed. So if I move to forward, the cardinal direction, pivotal cardinal direction is backward, and if I quickly switch to the backward, the pivotal cardinal direction is forward, right? So we can use this variable to make a decision on which pivotal animation we should play whenever we do a quick pivotal change, right? So now I can get rid of this log string, and let's jump back to our anim node function, setup pivot anim. There actually we can now use this cardinal direction from acceleration to make a selection, right? Okay, now as usual we need a set of cardinal direction animation data structure that has been attached to here. So let's set up that thing. So I'll go to the anim jog as usual, and let's add a new variable called pivot cardinals, and make sure the type of it is SNM cardinal type, and I'll move it like this. Save the thing, go to the anim set, save the thing, good to go, and go to the data table and save it, and go to the component level, compile it and save all. Right? Okay, we don't have any runtime issues then. Now let's go to the ABP locomotion animation blueprint again, and I think it should be what? It should be a blueprint, not thread save function. Inside this set animation data, inside this cardinals, it should be having a new exposed pin, which is pivot cardinals. So let's promote it to a variable called pivot cardinals, and I'll add it to the anim sequences category, and then plug it to here. Compile and back. Now let's go to the setup pivot anim layer function again, and there we can call this variable, split it, and attach the pins accordingly. Okay, now we have that attachment to determine the pivotal state. So let's go back to the anim graph locomotion and view it here, right? On become relevant function. Yeah, similarly what we have been done for the start state, I think we need to add the update pivot anim layer function as well. So let's quickly add this thing, but it may involve different calculations later on, but for now let's go with the most simplest approach. So I'll name it as update pivot anim layer and move it to the anim node functions category. And similarly, what we have been done at the update stop anim layer, I'll copy this thing and paste it here for now, right? Node is here and context is here. Okay, now we have that one update at the sequence level as well. Okay, now the state is, I believe, fine. Now what we have to do is we have to define the transition logics properly at the locomotion state machine level. Yeah, so I'll first start with first let's start with the valid path. So let's say pivot sources to pivot state. So how we can do that? Yeah, so first I think we need to create as validity function like we did here. To do that, you have to go to this set and invalid and create somewhat similar functionality like this. And I think this would be the last cardinal validity function because we have start stop already, so this should be the final validation function. Yeah, let me quickly check my documentation. Yeah, this is the final one. So let's get the pivotal cardinals, break it, and I'll copy these 4 variables and 4 functions and attach to here, right? And then promote it to a variable. I'll name this as is valid forward pivot. Drag it to here. Similarly, is valid backward pivot and is valid left pivot, and finally is valid right pivot. Plug it to here. Right. So I'll add a comment as well called pivot cardinal validities. Okay. Now we have those validity variables. Now let's create a validity function for that pivot state. So inside this anim set, I have this is valid stop anim. So let's duplicate it. And I'll rename this as is valid pivot anim and move it to the anim set category. And instead of using these 4 variables, now I have to use these 4 variables, right? So it's valid forward, backward, left, and right. And finally, let's move it to the anim validities category as well. Okay. And where we can assign this last velocity direction thing. Let me see. Yeah, let's assign this last velocity direction to the world velocity category. Okay. Now we have this is valid pivot anim validity function. So let's go back to the locomotion state machine. So we were here, right? Okay, now here inside this thing, there are multiple different checks that we have to be done. The first thing is obviously we have to check whether we have a valid pivot anim, and we have to check whether we are moving opposite direction of the acceleration. So how we can do that? We can simply get the local velocity 2D and local acceleration 2D, and we can do a dot product, and this dot product is less than 0, which means we are moving to the opposite direction, right? So this is a valid check to determine whether we are moving to the opposite direction or not. So I'll add a comment called check if velocity is opposite to acceleration direction. Yeah. So that's the second condition. Later on, actually, we can add multiple different checks, but for now, I think these 2 conditions would be fine. Yeah. So if we have a valid animation for the pivot, plus if we are moving or if we are accelerating to the opposite direction for the velocity, then we should make a pivotal transition, right? So that's the first transition. And then for the countermeasure, we can go to here and what we can do. Um, yeah, maybe let's keep this one for now. And we can implement this pivot to other state transition, right? So where we start. So easiest thing is this one, idle alias. So let's start from here. So this is pivot to idle states. So it's quite simple. We have to check whether we not have an acceleration, and is valid. Pivot any is not valid. You can do a transition as well, right? Maybe we can add a or logic here or boolean gate here, but yeah, for now let's use this AND gate, and later on let's do the refactorings, right? So that's the first jump, and this jump also I think we can do this same validation, right? But let's see if we have a valid stop penny. This can be the possible jump, right? Because we have a valid stop penny. So let's copy this thing and paste it here. But instead of not, now we have a valid valid stop penny, not this one, valid stop penny, and we make a jump, right? And I think this transition also, it should be is valid stop anim check, not the pivot anim check, right? Because it's a countermeasure, right? So I'll explain it again. So from pivot to stop, if we have a valid stop anim and if we doesn't have an acceleration, then we jump to what? Jump to stop state. But let's say if it doesn't have an acceleration, but if it doesn't have a stop valid animation to be played also, then we can't do a possible jump to the stop state. Instead of that, we jump to the idle aliases. And the idle aliases is pointing to the idle state, which means it is exact similar to make a jump from here to here, right? So it's a countermeasure. Okay, and then we have this transition from pivot to cycle, and this is quite straightforward. So if we have an set change, then we jump from here to here plus let's say what maybe let's say if we are moving perpendicular to that specific initial pivot point, we can do another transition as well, but I think maybe the initial stage this implementation would be fine, and later on we can improve this thing, right? And now we have completed this one, this one, this one, and this one. So the remaining part is this transition. So here as well, what we can do is we can do a similar check like this to check whether we are moving from opposite direction from the velocity direction. And what else? And if we have a valid pivot anim also, we can do a proper valid transition. And if we have a valid stop anim, we can do a valid transition, right? So if 3 of these conditions satisfies, then this countermeasure has been applied from pivot sources to stop state, right? Okay, so those are the initial state transitions, and let's play a test. Okay, yeah, I think I have forgot to implement the pivotal state at the data table level. Right, so let's go to the data table, and inside the pivot cardinals, let's implement those stuff real quick. Numped jog, forward pivot, backward pivot, left pivot, and finally right pivot. Save all. Let's play test. Yep, you can see that pivot animation has been applied properly. See, if we make a quick transition for the opposite direction, it do a proper pivotal animation instead of directly jump into that specific cycle cardinal direction. For the left side as well, you can see that pivotal animation is playing first, right, before making this quick transition. I think the forward and backward is pretty much obvious that pivot animation is applied. Left and right animation also it is applying, but it is almost insignificant. But overall it had a good realism to our game, right? Okay. Great. And maybe I can show you side by side if we disable this thing, right? See, if I disable all and play it again, you can see now there is no pivot transition, right? It quickly jumped to that specific anim to opposite direction based cycle cardinal direction animation. So for example, if I move to forward, it go to the forward, it plays the forward cycle animation, and if I suddenly change the direction to the backward, it suddenly plays the backward animation, right? And for the left side also same thing, right? So it is fine, but the realism is the issue, right? But if I make it pivotal like before, where the start, cycle and stop are possible pivotal sources, so now the pivot jump should happen. For example, let's see if I move to forward and suddenly change the direction to the backward, it doesn't make a quick transition for that specific animation, right? Instead it slowly make a smooth animation transition, right? Even for the left and right side, I think it's pretty much obvious, right? So there are no sudden animation transitions like we had before, right? Okay, great. Now I think those are the pivotal changes. Plus, before wrapping this up, maybe we can test out the forward facing mode as well, but ideally it should work like we expect. Yeah, you can see that minor issue, which is foot sliding, is there, but overall it works, right? The pivotal animation has been applied. See? Okay. But I think the strafing mode is the one which is working almost 100% perfectly. But yeah, later on, as I said before, we can make some improvements for that forward facing rotation mode as well. Yeah, so that's how we implement the pivot transition for the character. And yeah, so thank you and see you in the next session.